In this video, we're going to do some matrix algebra on the TI-84 Plus Silver Edition. And of course, this one's a virtual calculator. I'd assume that you know the basic concepts of matrices. I'm just going to say that a matrix is a rectangular array of numbers arranged in m rows and n columns. So the dimension of the matrix is given by the number of rows and columns. So the first one we have here, A, is a 2 by 2, 2 rows, 2 columns. The same thing for B. C is a 2 by 3, 2 rows, 3 columns. D is a 2 by 3. E is a 3 by 2, 3 rows, 2 columns. And F is a square matrix, 3 rows, 3 columns, 3 by 3. And so we have some operations we're going to perform using the calculator here. And first thing I'm going to do is enter these in matrix form on the calculator. I've done most of these to shorten the video a little bit, so go to second and then matrix over here in the calculator. So go to second and then matrix. And you notice the ones that have dimension already on the right I've already entered. So I need to enter A and C. So you go to edit. Select number 1, which is A. And first I give the dimension, which is 2 by 2, so go 2, and then enter, and then 2, and then enter, and then enter the components. 1 for the first row, and then a 3. Second row is a -2, enter, and then a 5, enter. And then we go back to the matrix menu. And this time I'm going to do C, so edit, and then number 3. And for that one, it's a 2 by 3s, 2 rows, 3 columns, so enter 2, enter, and then 3. Then we enter the components, 0, enter, 1, enter, -6, and enter. And for the second row, 1, enter, 5, enter, and then 4. We'll quit here. And then the operations we want to perform on these, number 1 over here, we want 2 times A, or 2 times matrix A, minus 3 times matrix B. You can do these manually. Addition, subtraction, just quick rules here. Of course, you can add or subtract matrices if they have the same dimension. Otherwise, it's going to be undefined. For matrix multiplication, you multiply and say A times B. The columns in the first matrix have to equal, number of columns in the first matrix have to equal to the number of rows in the second matrix. That's because of the way the multiplication is defined. So here I'll do it 2 times A. So go to the matrix menu. We want A, so enter 1. Then -3 times matrix B, so go to the matrix menu. You want B, that's 2. Hit enter, and we get the 2 by 2 answer. Components of -7, 6, 2, -11. Clear this. For number 2, C, matrix C minus 2 times matrix. So go second, well, let's see. Enter, yeah, go to matrix menu. You want C, that's number 3. And then it's -2 times matrix D. So second, matrix menu again. Access D, which is 4. We'll see -2 times matrix D. Enter. We'll get components for the 2 by 3 answer here. -8, -1, -6, 7, -3. And 8. Clear this. Now for number 3, I have matrix A times matrix C. Now the multiplication there is defined because for A is 2 by 2 and C is 2 by 3, so the number of columns in the first matrix you're multiplying does equal to the number of rows in the second one. Now should you multiply it in the other order, C times A, the calculator will give you an error because that's not defined, doesn't satisfy the conditions. But in this case it is, so go to matrix menu here, 1A, And then matrix again, menu. We want C. This is number 3. Hit enter. And there we have it. The answer comes out 2 by 3. Clear this. Okay, for number 4, again, is a product. Fine, because the number of columns in the first one does equal to the number of rows in the second. So we can just go ahead and access each of those and multiply. Second matrix. We want F. That's 6. And the second matrix. We want E. That's 5. Hit enter. And it comes out as a 3 by 2. Let's clear this. Now, for number 5, we want A inverse. That's what it means. A to the negative 1 in matrix notation means we want the multiplicative inverse of matrix A. Kind of like with numbers. If I say, what is the multiplicative inverse of 2? But it would be 2 to the negative 1, or 1/2. 2 times 1/2 is 1. Gives you the identity matrix for multiplication. The identity for multiplication with real numbers is the number 1. Okay. Access the matrix A. That's 1 again. And we want to put a negative 1 of an exponent there. So go to the caret here, and then negative 1. And most of the time when you're working with matrices and you're finding the multiplicative inverse of a matrix, that's kind of tedious. Adding matrices, subtracting matrices, multiplication, a little bit more involved. But finding the inverse, especially if you have like a 3 by 3, 2 by 2 is not too bad, but a 3 by 3, manually finding the inverse can be kind of tedious. And most of the time you're going to get fractions here. So we want the answer in, gives you the answer in decimal, so we want it in regular fractions. So let's go to the math menu here, fraction, hit enter. So that's going to give me the answer as a fraction. And there it is. That's the multiplicative inverse. Now, if I were to multiply this multiplicative inverse by the matrix A, I should get the identity matrix for multiplication for the 2 by 2. So let's do this. Let's say multiply this, and then we want matrix A. Let's be 1. Hit enter. Again, I always get this identity matrix for multiplication. If it's a 2 by 2, it'll have the 1s. It'll be 1s along the main diagonal. If it's a 3 by 3, it'll have 1, 0, 0, 0, 1, 0, 0, 0, 1 for the first, second, third row. But it'll have 1s along the main diagonal and 0 everywhere else. So that kind of verifies or confirms that the answer that we got with the calculator is correct. Again, with numbers, 2 times 1/2 or 2 to the negative 1, those are multiplicative inverses. You get 1. So 1 is the identity for multiplication when it comes to real numbers. And of course you have the same sort of thing with matrices. Now, clear this. For number 6, we want F inverse. And point out to you that only square matrices are going to have a multiplicative inverse. A 2 by 2, a 3 by 3, 4 by 4, and so on. But not all of them will have it. If it turns out that the determinant of the matrix is 0, there's no multiplicative inverse. If you try to do it in the calculator will give you an error. But these do have one because the determinant is not 0. So let's do, again, matrix menu, second. And we want F, so that's 6. And then exponent of -1. Hit enter. Again, it gives it to me in decimal form. So we want the components in regular fractions, so go to math. Number 1, hit enter there. And then hit enter again. And there we have it. Okay, so that's F inverse or the multiplicative inverse of f. Now to confirm the answer using the calculator, let's multiply this by matrix F. So go to second, matrix F is 6, multiply this, and you should get the 3 by 3 identity for multiplication. Hit enter, and there it is. 1 along the main diagonals, 0 everywhere else. Thanks for watching. We'll see you next time.